Hello everyone. Let's see this amazing question. Three particles A, B and C start moving simultaneously with constant velocities from three places. The starting places are collinear and that of B is somewhere in between A and C. In the absence of C, particles A and B would have collided T1 time after they started, and in the absence of B, particles A and C would have collided T2 time after they started. What would have happened if A were not present? So we are taking the three particles and taking them as three ants. Let's see the options one by one. So first option, if T2 is greater than T1, particles B and C may or may not collide. Let's see this. So if let's say A goes along this line and T2 is the collision between A and C, right? And T1 is the collision between A and B. Okay. So between A and C, collision happens, let's say at some time T2. So that time must be later, right? T2 is greater than T1. So A is going along this path. At T2 time, it is here. At T1 time, it may be somewhere here. Okay. So this is at T1 time and this is at T2 time. So B would have reached here and they collide. And then again C would have reached here and A and C collide here. So if T2 is greater than T1, like in this case I've taken T2 is greater than T1, B and C may or may not collide. So that's correct because when this T2 time is later, this line and this line can be parallel. So they will not collide. Or it can be diverging also. T2 can be somewhere here, right? And then also they will not collide. But what if T2 has to be a time which is later? So it can be here also. But then in that case, what will happen? Somewhere they can collide. Okay, B and C may collide also. Now, if T2 is greater than T1, particles B and C collide in the interval T1 to T2. So we have just discussed that if T2 is greater than T1, what happens? So B does not happen. That's not correct. Okay, B is not correct. A would be correct. Okay. Then let's see option C. So if T2 is less than or equal to T1, particles B and C must collide at an instant T less than or equal to T2. So if T2 is less than T1, that means this collision happens somewhere here, right? T2 is less than T1. I'm checking option C now. So in this case, they are saying that particles B and C must collide at an instant which is having T lesser than equal to T2. Now here you can see that these two lines intersect. So you might think that this must be colliding, but that may not be correct. Okay, that may not happen. For two particles to collide, they have to be at the same position at same time. So we'll have to prove that. Okay, so what we can do, we can take the angles, let's say alpha, beta, gamma. Okay, let's name the points also. Let's call it D, E, and F. Right. So these angles are alpha, beta, gamma. Then what will happen? What will be this angle? This angle will be beta minus alpha. Okay. And what will be this angle? You can see this angle from exterior angle in this triangle. It will be what? Alpha plus gamma. Alpha plus gamma. Right. And then this angle will be 180 minus beta plus gamma, and same here. Okay, if we need it, we'll see. So let's see what we can write here. So see, what we have to prove is that the ratio of BD to CD is same as the ratio of velocities, the ratio of speeds. Then only they will be at the same position at same time. Okay. So what we are going to consider, let's consider that B reaches point D in some time, let's say TB. and C reaches D in sometime TC. So we can, if we prove that TB is equal to TC, we are done. We know that the particles will be at the same position at the same time. So let's see what we can do about it. What we can write here is that BD by sine gamma is equal to CD by sine beta. Okay, that becomes one equation. Then let's involve this triangle and let's write the values of gamma and beta from there. So this angle will be 180 minus beta, right? So what we have here is that AF by sine 180 minus beta, which means sine beta, right, is equal to on the other side, if we have AF by sine beta, this length we know, right? This length will be VA into T1. This will be equal to this length FB divided by sine alpha. FB by sine alpha. Okay, now let's take this triangle. So in this triangle, what we can see? In this triangle, we can see that AE by sine gamma, AE by sine gamma is equal to um, EC by sine alpha, right? Now let's divide equation number 2 and 3. So what we would get? We would get that sine gamma by sine beta, sine gamma by sine beta, and here we would have AF by AE, right? AF by AE is equal to, here we have FB by EC. Sine alpha gets cancelled. So what we are getting is that sine gamma into sine beta divided by sine beta is equal to FB by EC into AE by AF. Okay, so we'll substitute this in our first equation. So we have that BD by CD is equal to sine gamma by sine beta, right? And from here we have that sine gamma by sine beta is this thing, FB by EC into AE by AF. So now see, what will be FB? FB is this length, and we have discussed that in T1 time it has to collide. So FB must be what? VB into T1, right? FB would be VB into T1. And what would be EC? This C particle is colliding here at time T2. So EC would be what? VB into T2 into AE. Now AE is what? This particle reaching here in time T2. Okay. So that will be what? VA into T2 by AF. AF would be what? This particle reaching over here at T1. So VA into T1. Now, I think I've made a mistake here. EC is not VB into T2. Yeah, it is the time, it is the length traveled by particle C in the time T2. Okay, so it should be VC into T2. So VA, T1, T2, T2 cancel. And we are done, right? See, BD by CD, we have got as VB by VC. Remember, earlier I told you that let's take the time taken by particle B to reach over here. Let's consider that as TB. and let's consider this as TC. So what we can write here, we can write that VB into time taken by B, TB, divided by VC into time taken by C, TC, is equal to this thing. Okay. So now what you can see, VB by VC you can cancel, no, from both sides. VB by VC you can cancel. So what you get? You get that TB is equal to TC. So the particles will be at the same place at the same time. So they must collide. Okay, and this is the time which is mentioned as T. This time must be lesser than T2 because at T2 time it reaches here, right? And it must be lesser than T1 also because T2 is already less than T1, and the time T that we are getting here for the collision between B and C is lesser than both of them. Okay, so that's why I check option D also once. If T2 is lesser than equal to T1, particles B and C must collide in time interval T1 to T2. So this is implying that T is between T1 and T2, right? Which is not correct. Hence, the another correct option is C. So A and C are correct. So this was a very amazing question. Hope you enjoyed it.